Let's study 9th standard ICSE Physics, Chapter 9, Current Electricity. Section B, Potential Difference and Resistance, and Section C, Efficient Use of Energy. Let's quickly revise the concept of potential difference in current electricity. If you have object A, which is positively charged, it's a conductor, it's positively charged, which means it is deficient in electrons. And there is an uncharged conductor. That means it is neutral. It is neither deficient in electrons, nor does it have excess electrons. If you connect them with the help of a metal wire, then electrons will flow. It has no excess electrons. But because this has deficiency of electrons, it feels compassionate towards it. And it will donate some of its electrons to A. This way, some of the positive charge here will be neutralized. So its positive charge will decrease. On the other hand, this will now become positively charged. So now it seems that both of them are equally deficient in electrons. There is an equilibrium, and that's what they always want. Equality. So we say that this was at a higher potential and this was at a higher potential and this was at a lower potential. Electrons always flow from lower potential to higher potential. Always remember that. And current is said to be flowing conventionally, traditionally, in the opposite direction to the flow of electrons. Now look at this diagram. We have a negatively charged conductor, which means it has excess of electrons, and it is uncharged. It's neutral, it's happy, but it has excess. So it will donate some of its extra electrons to B so that its negative charge will decrease. And this will become slightly negatively charged. And now both are equally negatively charged. They are in equilibrium. And then the electrons will stop flowing. But while the electrons were flowing, we say that current was flowing. In fact, current would be in this direction. We would say this is at a higher potential, and negatively charged means it is definitely lower potential. Next example. A negatively charged and B positively charged. This is a very clear case. Obviously, electrons will flow from A to B because this is excess electrons, this is deficient electrons. But current is flowing from B to A. This is the higher potential and this is the lower potential. This is similar to the beaker example which I had explained in section A. So study this diagram, although you don't have to practice it. The theory is whatever I've explained, so if you wish you can read it, but no need to learn it. Another analogy is that of heat. If you have an object at a high temperature and an object at low temperature, heat always flows from high temperature to low temperature. Notice that object B is bigger than object A. It is also possible that object B has totally more heat energy, more joules or calories compared to A. And yet, heat will flow from A to B, that is high temperature to low temperature. Even here, it's possible that the total volume of water in B is greater than the total volume of water in A. And yet, water will flow from A to B because here all that matters is the water level. So this is the diagram you have to draw. It's double ticked. Electrons are flowing from positive conductor to negative conductor, that is high potential to low potential, is the flow of current. Electrons are flowing from low potential to high potential, that is excess electrons to deficiency of electrons. More the difference between them, more is the current which will flow. Just like even here, more the potential difference between the water levels, more is the flow of water. But how do we calculate this potential difference? Well, it is calculated by a unit called volt. Hence it is also called voltage. And the potential difference between two conductors is defined as the work done in transferring a unit positive charge from one conductor to the other conductor. Which means if I have a unit positive charge, let's say 1 coulomb, and I transfer it to the other conductor. So the work done in doing so is called the potential difference. Let's say the work done is 2 joule. So it's 2 joule per coulomb, which is also called 2 volt, because 1 volt is nothing but the work done being 1 joule when 1 coulomb of charge is being transferred from one conductor to the other. So this is the SI unit of voltage or potential difference, and it is also a scalar quantity. So this is the definition of 1 volt. Next, electrical resistance. The definition is the obstruction offered to the flow of current by a conductor, don't say wire, is called its electrical resistance. And I had explained the cause of resistance. In any metallic wire that is a conductor, there are many free electrons because metals have those valence electrons which can freely move about. That's why they are good conductors, because they have free electrons. However, when there is a potential difference applied between the two ends thanks to this cell or any other source of electricity, then the electrons will be disciplined and start drifting in a particular direction, which is actually from negative to positive. However, current is always marked as from positive to negative. So, because of the potential difference, the direction of electron flow is in this direction. However, when they are moving, they will collide with the atoms or ions or other electrons in their path. That is called resistance. So they will collide, they will slow down, again they will accelerate, they will collide, they will slow down, again they will accelerate, and so on and so forth. It's not a smooth flow like the river. It's a drifting from one point to another. So obviously insulators would have very high resistance. That is why electrons can't flow through them easily. And as you can guess, if the resistance is high, the current is very low, and vice versa. On the other hand, if I increase the potential difference, let's say put another cell and another cell, so this whole battery will give you more potential difference, so more current will flow. So clearly potential difference and current are directly proportional. More the potential difference, more the current flowing. This is the Ohm's law, which is very important. Ohm's law states that if a current is flowing through a wire, when there is a potential difference across the wire, then the resistance is nothing but the ratio of the potential difference to the current. Now this is something you will study in depth in 10th standard, but let's just analyze this. If we assume the resistance of a wire to be a constant, let's say the resistance of a wire is 3 ohm. Yes, ohm is the unit of resistance. That means that potential difference and current are directly proportional because their ratio is a constant. If I cross multiply, this is the formula. It's useful because with this I can calculate either V, I or R. So here, let's assume that the resistance is 3 ohm and I am using a 6 volt battery. Now, without using an ammeter and experimentally demonstrating it, just calculate and tell me how much current is flowing through the wire. Well, voltage, as I said, is 6 volt, current is I, unknown variable, resistance is 3 goes down, so current is 2 ampere. So such numericals are there in this chapter. It's so easy. Current is 2 amperes. If I double the voltage, if I make it 12 volts, current will also double. It will become 6. Double of 2 is 4 amperes. The resistance is constant, of course. So you can see that as voltage is increasing, current is always also increasing. They are directly proportional. And their ratio is a constant which we have termed as resistance. So if resistance is volt upon ampere, then that volt upon ampere can be called as ohm, the SI unit of resistance. So now let's define 1 ohm of resistance. The resistance of a conductor is 1 ohm when 1 ampere of current flows through it, when the potential difference is 1 volt. So if you remember the formula, you can easily remember the definition. And finally, let's study the 4 factors which affect the resistance of a conductor. First, the material of the wire. This is a give reason. Obviously, the material matters. Some materials like gold and silver have very low resistance. That's why they are fantastic conductors of electricity. If the wire is made up of a very bad conductor, it's simply because its resistance is very high. That means the insulators hardly have any free electrons, whereas aluminium, gold have a lot of free electrons. Next, the length of wire. It's obvious that if the wire is short, then the electrons have to face less hurdle from going to point from one point to another point. But if the wire is long, then to complete the entire journey, they have to overcome so many hurdles. It's like a vehicle on a highway. If it's just a short path, you'll face less hurdles. But if it's a long journey, you'll have to face a lot of resistance. So length affects resistance. In fact, it's directly proportional. If you double the length of a wire, resistance is also doubled, assuming that all the other factors are constant. The third factor is area of cross-section of a wire, which simply means the thickness of the wire. Now imagine again you are driving on a road. If the road is narrow, then there will be a lot of resistance or traffic congestion you will face. On the other hand, if the road is broad, then you will be able to drive with lesser resistance in your journey. Similarly, if the wire is thick, the greater cross-section area, resistance is low. But if the wire is thin, less cross-section area, resistance is more. So you can see it's inversely proportional. If the area of cross-section is doubled, the resistance will be halved, assuming that all other factors are same. And the fourth and the final factor which affects resistance is the temperature of the wire. Imagine you have a hot wire. Now, if it's hot, it means the particles inside the wire have a lot of kinetic energy. If there's a lot of kinetic energy, that means the number of collisions with the electrons will be far greater, and so the resistance will be high. It's like this: if you are driving on a hot day, super hot day, and everybody's feeling very hot, there will be more commotion on the highway. On the other hand, if it's a pleasant day, cool environment, you will face less resistance while driving. Next, we have solved examples, out of which second one is quite interesting. Third, fourth, fifth, sixth, these four are numerical, so please solve them. They're very simple, just one same formula. Two variables are given and one variable has to be found out. Similarly, in exercise we have four sums, so please solve them using the same formula. Be careful about the units, however, and mark the answers of the exercises. Next, section C, efficient use of energy. Well, this is just general knowledge. What is the meaning of efficient use? It means that we should reduce the cost and the amount of energy to be used. This way we will be eco-friendly. We will save planet Earth. It has two benefits: our cost of energy decreases and emission of greenhouse gases also decreases, so that global warming would be avoided. What are the examples? There are many examples. I've selected a few for you to learn. First of all, let's insulate our home properly. Especially in cold countries, a lot of electricity is used or fuel is used in heating the houses. But if you insulate the home properly, use proper material to build the house, then it will be comparatively warmer even without a heater. Another example, use CFL bulbs or LED bulbs. They are far more superior and more efficient than the usual incandescent lights which were used in the past, like the tungsten filament bulb, which is so wasteful. Most of the electrical energy is wasted as heat energy there. Another example of efficient use of energy is the building's location should be chosen and its configuration should be such that we use the wind, the breeze, the sunlight maximum, so that we don't have to spend electricity in having light in the house or keeping a house cool. The windows should be built in such a way that it's efficient. White roof systems can save more energy in summers. If the roof is black, it will absorb a lot of heat and you will require greater air conditioning power and electricity will be consumed to keep your house cool. But if your roof is white, it will reflect most of the sunlight. So if your budget is tight, you can save electricity day and night. Another technology to show its might, come on, this is the height. We should use vehicles which are fuel efficient. Modern technology has given us electric cars, so fossil fuels will no longer be required in the future. But it's not just about the fuel, even the tires should be advanced. Computers can be used in the car to make it more efficient. Now, what are the social initiatives we can do for efficient use of energy? First, develop the energy efficient machines and the technologies which can reduce the energy expenditure. Public awareness is very important. Through mass media, we should have children's participation. There should be campaigns, eco-club activities to spread awareness. Even NGOs, that is non-government organizations, they are non-profit organizations, can create social awareness.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.